Today we are covering the quadratic formula and the discriminant. We'll talk a little bit more about those here in a moment. 8-week progress reports will go out the end of this week. I'm not exactly sure when they get generated, but any Chapter 8 homework that you still need to complete needs to get done. On Saturday, I plan on closing that all out, so you won't be able to do any Chapter 8 stuff. Today, I'm planning on going through the Chapter 9 lessons 1 through 3 and the quiz, all of that work, marking anything missing that's missing. And then next week, we will be quizzing on the second half of Chapter 9 on Monday and Tuesday. So you'll have the review and the quiz. A reminder, get all your Chapter 9 homework in. Again, it's we're kind of coming down to the end, and work that's not completed is going to have a negative effect on your grade. So make sure you get turned in what you can. All right. So let's go on to our notes for the day. All right. So again, this is in our yellow packet, last day of the yellow packet, starting on page 23. So this is another method for solving quadratic equations. And it actually works for any quadratic equation. Again, as long as it's in standard form, this will always work. It's the only method that will work absolutely every time. You know, factoring only works if the function is factorable. Graphing in the table work best when our x-intercepts are integer values. You know, and there are certain limitations to different methods. So if we are going to use the quadratic formula, that's a formula that gives the solution of quadratic equations in the form ax squared plus bx plus c equals 0. Again, sometimes we just call that standard form, where a, b, and c are any real number. It is especially useful when the equation is not factorable and when a is not equal to 1. It still works if the quadratic is factorable. It still works if a is 1. It just works kind of best if one of those two things are true. Excuse me, I didn't think you needed to see or hear me sneeze. So the quadratic formula gives us the solutions to a quadratic equation. And the formula says our x value, our solution, is equal to the opposite of b plus or minus the square root of b squared minus 4ac. This is going to become very important to us in just a moment. All divided by 2a. And so that's why having a graphing calculator or a scientific calculator today is going to be very important. We're going to do a lot of calculations. So the discriminant is that part of the quadratic formula that I just circled. It's the part that's underneath the root or inside of the radical. The expression b squared minus 4ac in the quadratic formula. The value of the discriminant determines the number of real solutions or roots or zeros there are in the equation. So if b squared minus 4ac is positive, if it's greater than 0, we get 2 real solutions. And that graph would have to look either like the one shown here in the table. It could also open down if a was negative. So, but it would cross the x-axis twice. If b squared minus 4ac equals 0, we have one solution. And so that is going to be a graph where just the vertex is on the x-axis. Again, it could open up or down, but it only crosses the x-axis once, or it touches the x-axis once. And if it's negative, if b squared minus 4ac is negative, we have no real solutions. The graph never touches the x-axis. So very important information. If you get nothing else from today's lesson, this information is hugely important, and we will use it throughout the day-to-day and for your homework assignment and your note check. All right, so calculating the discriminant. Find the discriminant for each equation and determine the number of real roots or real solutions. So what I would do is start by listing out our values for a, b, and c. A is the number in front of the x squared, that's 1. B is -6. C is 8. So remember to keep track of the signs, they are important. So the discriminant, and I'm going to use a capital D for the discriminant, is going to be b squared minus 4 times a times c. So -6 squared, that's -6 times -6 is positive 36. 4 times 1 is 4, times 8 is 32. So the discriminant is 4. And yes, you could certainly use your calculator to find, to find the discriminant. Because the discriminant is positive, we have 2 real roots or solutions. Right. Another example here. So here we have A equals 2, B equals -9, C equals 11. So the discriminant, A squared minus, sorry, B squared minus 4AC. And yes, it's important to have those parentheses. Okay. And again, you could use your calculator. So in this case, we have -9 squared minus 4 times 2 times 11. And our calculator does order of operations. So this says we get -7. If you don't have a calculator to use, you can go -9 squared is 81 minus 88. So we get -7. And this one would have 0 real roots. All right. So here is, there are actually 2 problems for you. Oops, no, sorry. This is one for me to do again, or for us to do together. So again, list out A, B, and C. Be careful with this one. A is -1, B is 4, C is -4. So the discriminant, -1 squared minus 4 times, try this one more time. It's going to be a long day today, I can just tell. 4 squared minus 4 times -1 times -4. And again, feel free, you can use a calculator to make this calculation. We would get 16. 4 times -4 is negative. 4 times -1 is -4. -4 times -4 is +16, and we have the subtraction sign. So be careful. Common mistake when the discriminant is 0, people want to say there are no real roots, but this is the situation where we have 1 real root. And very important that we have that. Now, your chance to do a few. Again, I'll give you a couple of minutes, and then we can take a look at the answers when that time is up. All right. So for these 2 examples, A is 1, B negative 10, C 25. The discriminant would be 10 squared minus 4 times 1 times 25. So there's always going to be that minus 4 when you're doing the discriminant. That's just part of the formula. It's 100. This is 100. So our discriminant is 0. Now here we ask for the number of solutions. This would be one real solution. Example 2, A is negative 1, B is negative 6, C is negative 10. So we get negative 6 squared minus 4 times negative 1 times negative 10. Negative 6 squared is 36. Minus 4 times negative 1 is negative 4. Negative 4 times negative 10 is positive 40, so we're subtracting 40. Discriminant is negative 4. So there are 0 real solutions. And again, in a couple of years, when you take Algebra 3, you will take a look at what happens then and what that means. And there are ways mathematically we can deal with that. All right, so you will also be asked to look at just the graph. Determine whether the discriminant is greater than, less than, or equal to 0. So we have I'll just use D for the discriminant. Your crosses, or it touches the x-axis at that one point. That's when we're equal to 0. Touches at 2 places. This means it has to be greater than 0. And if it doesn't touch the x-axis, our determinant is less than 0. So how to solve using the quadratic formula? Write the equation in standard form, so it's equal to 0, and label A, B, and C. So we've been doing that with the discriminant. It's kind of helpful to do that first. Substitute the values for A, B, and C into the quadratic formula. Simplify the discriminant first. So this is huge. I would find the discriminant first. And then whatever the discriminant, if it is greater than or equal to 0, then I can go to the quadratic formula. If it's negative, we can stop because we're not going to find any real solutions. Write out your answers, one for the positive and one for the negative, for the plus and minus part. Use a calculator to evaluate both expressions. Round answers to the nearest hundredth. And again, I'll show you a nice little trick that we can use with our calculators. All right, so that's using the quadratic formula. And so we'll do a couple of examples. First thing we need to do, get the equation in standard form, so subtract the 4x. A is 1, B is -4, C is -7. So I'm going to start with the determinant. -4 squared minus 4 times 1 times -7. So this would be 16 minus -28. And subtracting a negative is the same as adding a positive. So the discriminant is 44. Now our quadratic formula says we're going to take the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Or this is our discriminant. So we actually save ourselves a little bit of work. So if I was going to plug into my quadratic formula, I would get the opposite of -4. That's +4. Again, there's my A, B, and C. So A is 1. That's also important to remember. Plus or minus the square root of the determinant, so the square root of 44, over 2 times 1. Now we don't need to simplify the square root. We'll just use our calculator to estimate our answer. So that means x is equal to 4 plus the square root of 44 divided by 2, because 2 times 1 is 2, or x is equal to 4 minus the square root of 44 divided by 2. And so if we use our calculator, use parentheses, 4 plus the square root, that's second and that x squared button of 44, and your parentheses, divided by 2. There's one of our solutions, 5.32. We're going to round to 2 decimal places. So that's 6 that's in the 3rd decimal place says round up. The second solution, you could type it in using parentheses and everything. Or the great thing about the Texas Instruments calculators and most other graphing calculators, if you do second enter, it shows the last thing you did. And we know we don't want plus this time. We want it to be minus. So we can highlight the plus sign, make it a minus. And then if we go second and the right arrow, we go right to the end. Although you could just press enter before that. And we get -1.32. Again, the 6 says take that 1 and make it a 2. So 5.32 and -1.32. And I should actually use the wavy equal sign because I'm rounding. All right. Go back for just a second. I moved pretty quick. All right, now the next example. So a couple of options on this one. You could move the x squared to the left. by subtracting x squared, and that'll work. What I would ask you or remind you to do is write this with the x next and then the constant, the 21 last. You could have moved everything else over to the right-hand side as well. It'll work either way. So if you did it this way, you would have a equals -1, b equals -4, c equals 21. So our discriminant would be -4 squared minus 4 times -1 times 21. So we get 4 times -1 is -4. -4 times 21 is -84. So that minus a negative becomes plus a positive. The discriminant is 100, so I know I have two solutions. So my solutions are going to be the opposite of b, so that's 4, plus or minus the square root of 100, divided by 2 times a, and a was -1 in this case. So the opposite of b, plus or minus the square root of the discriminant, times 2, divided by 2 times a. So if I write these both, my two solutions separately, I would get 4 plus the square root of 10, square root of 100. 2 times -1 is -2, so divided by -2. And 4 minus the square root of 100 divided by -2. Again, calculating. 4 plus the square root of 100 in the parentheses. Parentheses are important, otherwise what happens if we didn't do the parentheses, our calculator would take the square root of 100, divide by 2, and then add 4, and that's not what we want. We want the square root of 100 plus 4, that answer divided by -2. So we get -7. And if we change the addition to subtraction, we get +3. Whenever you get integer values, more than likely the equation itself could have been factored. So there are my two solutions. Go ahead and try this one. And again, we'll come back and take a look at the answers here in a moment. All right. So taking care of this problem, first thing I would do is add 2 so that our equation is in standard form. A is 1, B is 5, C is 2. The discriminant, 5 squared minus 4 times 1 times 2. 25 minus 8, which is 17. So my solutions, the opposite of B, so -5 plus or minus the square root of 17 over 2 times A. Again, just to make it easier, I'm going to write these as 2 separate answers. Blah. It's a terrible X. And I'm going to clear so that I, oops, parentheses, -5 plus the square root of 17 divided by 2. And we get -0.44 if we round to the nearest hundredth. And now I want to do the same thing, except I want this to be minus the square root of 17. So again, making sure we're using the right symbols. I use the negative in front of the 5 and the minus in front of the square root. And this would be -4.56. So -0.44 and -4.56. All right. Moving along. So now we have examples where A is not 1. So this can cause some other interesting things to happen. Again, we still need it in standard form, so subtract 10 from both sides. A is 3, B is 4, C is -10. So our discriminant is B squared minus 4 times A times C. (16) minus 4 times 3 is 12, times -10 is -120. So subtracting a negative is the same as adding a positive. So our discriminant is 136. Our solutions then would be the opposite of B plus the square root of 136 divided, well, plus or minus, I'll do them as 2 separate, divided by 2 times A. So X is -4 plus the square root of 136 divided by 6, or -4 minus the square root of 136 divided by 6. Got to remember the parentheses. So 1.28 and negative 2.61. And again, those curved equal sign just mean that's approximate. We don't have an exact value. All right, another example. We're going to add 3 to both sides. Now, if we were going to try to factor this, we would look for a greatest common factor and take that out and deal with it and then try to factor. Because we're using the quadratic formula, we don't have to worry about that. That's one of the nice things about the quadratic formula. So our discriminant, 4 squared minus 2 times A times C, (16) minus 2 times negative 2 is negative 4 times 12 is negative 48. I'm going to recopy here what A, B, and C were because I don't remember. A was negative 2. B was 4. And C was 12. So our solutions would be the opposite of B plus or minus the square root of D over 2 times A. And 2 times negative 2 is negative 4. So negative 4 plus the square root of 64 divided by negative 4. And we get an answer of negative 1. And the other solution gives us an answer of 3. So more than likely, we could have done factoring, but we used the quadratic formula instead. And these are exact. We didn't have to round. X equals negative 1, X equals 3. All right, so another one for you to try, and we'll take a look at the solution in just a moment. right. So again, getting this in standard form. A is 2, B is -10, C is 5. I'm going to rewrite them over here because I know I'm going to need them later. Discriminant, D is B squared minus 4 times A times C. -10 squared is positive 100. This one might be easiest to do. 2 times 5 is 10, times 4 is 40. So remember, when you're just multiplying, you can multiply in any order. So the discriminant is 60. So my solutions are the opposite of B plus or minus the square root of the discriminant divided by 2 times A. The opposite of -10 is positive 10. And I'd add the square root of 60. 2 times A is 4. Or I take the opposite of B minus the square root of 60 divided by 4. So I get about 4.44 if I round. And uh, 0.56. So 4.44 and 0.56. All right, last bit here. So if you remember last chapter, we talked about vertical motion problems where the height at any time t is equal to -16 t squared, t squared plus v sub 0 times t plus h sub 0. And we describe what each of those things mean. And we talked about how long it takes to reach the maximum height. And if you remember, that was the opposite of v sub 0 divided by 2 times -16. Or if you simplified that a little bit, the negatives would cancel. You get v sub 0 divided by 32. The maximum height, we would take that answer and plug it into our equation. That would give us the maximum height. And now we have this new piece, find the time it takes to hit the ground. Well, we're going to use the quadratic formula for that. I don't need a parenthesis or a comma there. So that's how we're going to determine how long it takes to hit the ground. Now, very important when you're doing this, if you get two answers and one of them is negative, we are going to ignore the negative answer. We only measure time in a positive, with a positive number. If something happened in the past, we don't say, well, it happened negative 15 minutes ago. We just say, oh, it happened 15 minutes ago. So here we have our situation. A rocket is launched directly upward at 100 feet per second. So there's our V sub 0 from a platform of 80 feet, platform 80 feet tall. So our formula is negative 16t squared plus 100t plus 80. What is the maximum height? When will it attain the maximum height? So it's actually easier to do it the other way around. Find the time it gets to the maximum height. The opposite of b divided by 2 times a. Again, that would be the same as negative 100 over negative 32. Negative divided by a negative is positive. So we can just write it as a positive. So we have 100 divided by 32, 3.125. All right, and then what is the height there? So it's 3.125 seconds. What is the height? Well, we plug in 3.125. Helps if I write the correct value we're going to plug in. And again, I'm going to use my calculator to figure that out. So another little trick, that 3.125 is my last answer. So if I go second and the negative sign, I don't have to type it all in. It's just going to plug in 3.125 there, or whatever my last answer happened to be, plus 100 times my last answer, plus 80. And so the maximum height is 236.25 feet. And I hope I got that right. Yeah, okay. So answering my question, the rocket's maximum height of 236.25 feet occurs 3.125 seconds after the launch. So there's a good little review of finding the vertex. The other thing that we can do is find, hey, when does it hit the ground? So now we've got negative 16t squared plus 100t plus 80. And we want to know when it hits the ground, when the height is 0. So that's why we can use this equation in the quadratic formula. A is negative 16, B is 100, C is 80. So our discriminant is 100 squared minus 4 times negative 16 times 80. Squared minus 4 times negative 16 times 80. So yes, you could do this in your calculator just like this. Enter. So our discriminant is 15,120. So that means our time when it hits the ground will be negative 100 plus or minus the square root of 15,120 divided by 2 times negative 16. And then minus as well. All right, going back to the calculator. Negative 100 plus the square root of 15,120 divided by negative 32. Negative 0.72. Again, we'll round to the nearest hundredth, 2 decimal places. And switch the addition to subtraction. That's not what I wanted. And we get 6.97. And remember, this negative 1 we throw out. So it hits the ground 6.97 seconds after it is launched. All right, go ahead and try this one. Brandon is up to bat. He hits the baseball straight up in the air. Its height in feet after t seconds is given by the equation negative 16t squared plus 48t plus 4. When will the baseball hit the ground? So we just want to find when it'll hit the ground on this one. And I'll give you, again, just a couple of minutes to try it. All right, so again, we're thinking about this as the equation negative 16t squared plus 48t plus 4 equals 0, because that's the height at ground level. A is negative 16, B is 48, C is 4. Negative 6, oops, nope. (48) squared minus 4 times negative 16 times 4. Again, I would suggest using a calculator. Not that you have to, just might be a little bit easier with the numbers that we have here. 48 squared minus 4 times negative 16 times 4. And so we get 2,560. So our times are the opposite of b, plus or minus the square root of d over 2 times a. So we would have negative 48 plus the square root of 2,560 over negative 32, or negative 48 minus the square root of 2,560 divided by negative 32. Plus the square root 2,560 divided by negative 32. So our first solution is negative 0.08. And our second solution is 3.08. So T be negative 0.08. And we ignore that one because it's negative 3.08 seconds after the ball is hit, it hits the ground. All right, so we will